All right, so we're going to do a couple of examples here in this video. So the first thing I want to address is when is the best time to use the law of sines, all right? So law of sines, the best time is whenever they literally tell you use the law of sines to solve this problem. Like those are usually the telltale, like they'll give you the formula half the time. So it kind of points you to that direction. More like in general, I guess, is the best times to use it is whenever you have, like when you know two angles. When you have two angles, that's really the sweet spot. If you've got two angles and a side, that is opposite either angle. Okay? So you have, we're going to do some examples here in a little bit where we're actually solving for an angle, but the best time, the easiest time is whenever it's angle, side, all right? When you have two angles and you know either one of these sides that are across from those angles, all right? So let's give ourselves an actual side length here. So I got 25 degrees, 20 degrees. We're going to call this 9, and we're going to solve this triangle, okay? So it's not too bad. So to start, I'm going to say I'm going to solve for this leg right here, the one that's across from the 20. So the way that formula works is if I say 9, which is across from 25, if I say 9 over the sine of 25, that's going to be equal to x, which is across from the 20-degree angle, sine of 20. And so I can solve for x just by multiplying by the sine of 20. So if I do 9 times the sine of 20, I'll take whatever answer that is, and then I'm going to divide it by the sine of 25. And that's it. X would equal 7.28. All right, 7.28 is equal to x. 7.28. And if I wanted to, I could go ahead and solve for this other one too. The way I get it is I first need this other missing angle. So because these all have to add up to 180, that's easy. I just do 180 minus 20 minus 25. So I get 135 degrees here. Oh, 135. I'm going to do something a little weird, but it's okay. You'll be fine. You'll be fine. I just saw an opportunity because I saw a special angle. And let's use this information to solve for, what do we want to call this? Let's call this y. We're going to solve for that missing side now. So I just got to run through the law of sines again. So I'm still solving for a missing side. So I'm going to continue using the one where the side lengths are up top and the angles are below. So I'm going to say y over the sine of 135, that's the angle that's across from y, is equal. Now here I have choices. I could either do 7.28 over the sine of 20, or I can just do 9 over the sine of 25 again. And either way, it's going to come out to the same answer. All right, so to solve this, I would multiply through by the sine of 135. I said I was going to do something funky. I am not going to do something funky. I'm just going to play the game. So I would multiply by the sine of 135 to clear it out of the denominator. 9 times sine. I was thinking to myself, oh, that's root 2 over 2. And so I was going to mess with that. All right, divided by the sine of 25. And this should be a pretty big answer. All right, 15.05. 06, I guess, if I'm rounding there. And that's it. We solve for every piece of information about this this triangle there. If you wanted to, you could find the area. That wouldn't be too hard, right? You could just use 1/2. Use your sine formula. Anyway, I got one more example here. This is from page 345 in our book. We have a book? Mr. West, you didn't tell us we had a book. All right. Oh. So, example 1 from the book here. A civil engineer wants to determine the distances from points A and B to an, so they want to determine from A to C, all right, the distances from points A and B to an inaccessible point C as shown. So I guess they're not able to come out and measure this directly because it's in the water. But this is a stationary point, and they're wanting to know the distance from A to C, which is the side that's opposite B, and they want to know this distance as well from C to B. So it's not too bad. We're going to apply the law of sines here, figure this thing out. So again, I know I can use law of sines because I've got 2 angles and a side. Oh, wait. I've got 2 angles, but I don't have the side that's opposite one of those angles. But it's not too hard to determine. I can get this angle up here pretty quickly. These all have to add up to 180, so 110, 130. This has got to be a 50-degree angle. All right, now that I have 2 angles and a side, now I can solve this thing. That's the sweet spot. It really is the sweet spot. 2 angles and a side. 2 angles and a side. All right, let's work this out here. I'm going to set up, I'm going to say, I'm going to solve for A first. So it's going to be A over sine of 110, because that's the angle that's across from it, is equal. Now I have to use these two because I don't know 20 and B. All right, I have to do one of these fractions has to be one that you actually know. So it's going to be sine of 50 in the bottom and 25 up top. Cool. Not too bad. All right, again, I'm just going to multiply by sine of 110. 25 times the sine of 110. And then I'm going to divide that by sine of 50. Oh. So I'm going to take my last answer, divide that by the sine of 50. All right, that's 30.67. And that was equal to A, 30.67. Okay. And if I wanted to solve for B, it'd be the exact same setup. All right. I would use B over sine of 20 is equal to 25 over the sine of 50. That part I don't have to change. All right. Solving it, I'm trying to get that B by itself, so I got to clear out this sine of 20. So I'm going to do sine of 20 multiplied by the 25. And then I'm going to divide that by the sine of 50. Divided by the sine of 50. You get 11.16. 11.16. And then lastly, take a look at it. Make sure that it makes sense. Like the proportions and everything. You got a short side. You got a really long side, which is 30. Yeah, the picture kind of makes sense. All right, that's it. On the next video, we're going to look at solving for one of those pesky angles. Okay,